there's this notion of configuration management, which is what enterprises struggle with. You know, you have masses of machines, and you need to be able to deploy very quickly the configuration that you need. So if you're starting up 10 machines in a public cloud, you're either going to pick a generic, say, Linux image, and then you're going to need to go in and configure that, or you're going to have created the perfect image and then you upload it to the cloud provider, and then you spin up 10 copies of those. Personally, I don't like sending VMs all around the place. It takes time and it's hassle. And I don't like using your VMs. I'm sorry, but from a security point of view, like, this practice of sharing VMs is really good from the point of view of just getting experience with something. Yeah, so that's, for me, is a great use case. So I'm willing to download your VM and try and isolate it so that I can perhaps get experience with your software project or whatever. But I don't really think, I don't want to encourage people to share whole VMs, yeah? Because that's just asking for trouble. You know, why do we need to do that? Can't we express what should be in a machine in a text file? Yeah, so configuration management is about having recipes and having ways to spin up a machine and quickly configure it so that within, you know, a minute of it booting, it's how you want it to be. So freedom, open source, I'll talk about that in a second. And pragmatic. I'm as tempted as I am, because I'm a geek, there's no benefit in me reinventing wheels that already exist. Generally when people reinvent wheels, it's a great learning exercise, so there's value in that. But most of the time, unless they're coming from a very different discipline or background, the wheel's going to look pretty much the same, and it's just going to have a different set of bugs. So I'm trying to use components that, and this is all based on other people's stuff. You know, I've got to be really clear on this. I'm not inventing software here. There's some glue that I'm applying. You know, it's probably the best way to describe it. But I want to be able to use components, and we've already talked about the hypervisor. That's obviously one component. You won't catch me coding one of those. And it should be scriptable. And what do we know about scriptable? It's fun. Do you like scripting? Anybody? Yeah, geeks in the room. So, to make this happen, you need a cloud platform. And you can't just go to the supermarket and buy a cloud platform. What is platform? Because I know that until someone explained it to me once, I just thought it was a marketing term. Whilst it is a useful marketing term, I can see that. You know, platform really means that you have an environment, let's say, where you can you have a set of typically integrated services, and it means that other people can kind of code for that platform, so then you have this ecosystem of products and services around it. So you need a cloud platform in order to do, like, spinning up a hypervisor is easy, yeah? On your command line you can just type kvm blah blah blah. But then you need to configure it, and you need to spin up multiple, and you need to have multiple, say, groups of machines that would belong on different test networks, and you need to do your networking and everything. So there's all this stuff that's involved in creating a virtual data center, and so you need software that will do that. That's the cloud platform. That is the meat of any of what I'm showing you here. And one of the things about the cloud platforms, and it took me quite a lot of research to find one that was right, is that they have varying levels of openness. And I'm not standing here saying, you know, all software has to be open, and, you know, we should, you know, burn developers' houses that get paid for writing software. Because if we did that, we'd miss a lot of good software, and a lot of bad software too. So someone from there's a new cloud platform, which I'm not actually using right now because it's like brand new, and they're just bringing out version 1. It's called OpenStack, and one of their guys wrote a brilliant blog post where he went through the 5 layers of open source when it pertains to you know, software projects. And with cloud, this is again really important. So you understand it. Like the lowest is like, here's the API. Everything else is a black box. But a company may open source the core of the product and then sell enterprise features, you know, obviously commercially. The other one is they might open source the project itself, in which case that could just be a tar file. Right, here's a tar file. So you'll see that with Linux driver, Linux vendors, well, sorry, vendors of like graphics cards and so on. They typically will throw a tar ball over the fence and go, it's yours, get on with it. Is that really open source? Yes, it's open source code, but it's not an open source project. So the development process, that's when you can see things like bug databases like Track or Redmine, and you can see roadmaps and stuff like that. That's the open source development. And so, and then finally, the most extreme form of open source is where you have a group of people that perhaps they form a board or something, or a project team, and there's a decision-making process, and so you can get involved in that. You could say, right, I want to join that group, and you get people to vote you onto it and stuff. So this is really important because whatever software you're going to end up using for your cloud platform, it's important to understand at what level this is, because then you can understand how much you're going to be able to change the platform, like if it doesn't do what you need, how much support it's going to have, obviously community involvement, etc., etc. So I just mentioned this because I found this a really useful way to think about open source software in general, but also in particular cloud platforms. So I will skip all the, I looked at this, I looked at that, then I was, it doesn't do this or it doesn't do that. And I'm going to ask you, how many people have heard of Open Nebula? That's a couple of people, all right. So here I am, cloud security expert, and I do say that firmly tongue-in-cheek. And I'd never heard of Open Nebula, but it's like an open source cloud platform. So it was like discovery of the year for me. It was a slap my head moment, really. And it's a project run out of Spain from one of the universities, and these guys have just been building a cloud platform which can be used in 3 deployment scenarios. You can use it as a private cloud, so running it on your own servers. You can run it hybrid, which means that you run it on your own servers, but you can cloud burst, meaning you can invoke services at public cloud providers. Or you can run it as, sorry, that was hybrid. And then you've got public, which is where you run your own cloud and you sell that service. So I could set up an Open Nebula instance on, say, if I had 20 servers, let's just say, and set up a small Open Nebula setup, and then there's an API which you could use, and I haven't seen the billing module, but I think there is a billing feature, but I'm not interested in that. But I'd be able to then charge you, do proper chargeback for your use of services. So you can actually run it like that. But what's cool about having an API that other people can use is that your test labs are no longer just your test labs. They're test labs that if you want other team members or project members or friends or whatever, you can give them access to individual hosts, of course, but you can actually give them access to the cloud platform, which means that they could create their own test networks, for example. So just briefly, like the private cloud with Open Nebula, there's a front end, and then there's cluster nodes. And when I say cluster, you might be the danger of saying the word cluster is that for many people that kind of starts getting them close to grid. And grid is, and Thomas is going to be talking in the Lightning talks about his use of EC2, and he's using it it's a great use case. It's a classic use case of cloud, which is you've got a load of compute tasks that need to be done. So you spin up a bunch of virtual machines at a cloud provider. You parcel up the work, chop it up, and then you just give it to those, and you say, right, go ahead and do that. And so, from a security point of view, like use case, that could be like password cracking, all that. But that's all perfect, like use case, and you're doing a time-money trade-off. Yeah, so you're saying, I'm going to spin up a bunch of VMs that are going to cost me X per hour to run, and if I want the job to run faster, I'm going to start up more VMs. Yeah, so that's the concept there. And as far as these cluster nodes, you can use them how you want. I mean, it's just look at it as a resource, a compute resource. So you can start up VMs as many as you need, whatever else. And so the front end controls that. So in my case, I don't have multiple servers. I have this single lease server. So I'm running the front end. The single server is acting as a front end and a cluster node. And that's fine. You can run it like that. And my goal is that I just want the one, I did my maths and figured out how much RAM I need on that server for my usual stuff. And then I'm like, okay, when I need to go over that, I'm just going to use public cloud services. And that's what's supported. I've already mentioned you can do this hybrid thing. It interfaces with Amazon, also with a company called Elastic Hosts. And then through another mechanism, the Red Hat's Delta Cloud, it interfaces with Amazon again, GoGrid, Rackspace, Red Hat, Rimu hosting, Terramark, and vCloud coming soon. And you can see the features, you can create instances, start and stop instances, blah, blah, blah. Why is this interesting? Why am I telling you about it? I'm telling you because from a single command line, you can type a command which will start up a virtual machine and manage the machine, so start up, shut it down, reboot it, whatever, through any of those providers, through using a combination of Open Nebula and Red Hat's Delta Cloud. So once you've got that, once you set up that, then your command to spin up a VM based on a template file is going to go off to one of those providers, but the command to actually instantiate is the same. That's kind of cool. Like one command, I can start up a VM anywhere, or I can start up many VMs. So Red Hat have kind of created this Delta Cloud to kind of act as a kind of cloud broker, but it's software you run. Yeah, so I will have on my single server a virtual machine that's going to be running Red Hat stuff, and Delta Cloud. So my Open Nebula instance will kind of interface with this VM in order to be able to spawn instances elsewhere. One thing to mention, since we are talking about pay-as-you-go, is don't forget to turn the stuff off. I've made the mistake a few times now, and funny enough, the cloud providers are not falling over themselves to implement things like notifications. Oh, by the way, you've been running those 500 Amazon instances for 3 days now. So you don't get it, and you look at your monthly bill and you're like, oh, yeah, I forgot. So it hasn't been mega money, but it's been kind of annoying. So one of the features is just going to be a real simple script to remind you that you're still paying for stuff, because you just forget about it. I tell you, it's out there, and it's started up, and you got distracted, and you never turned it off. So just worth bearing in mind. And then the other thing is, just because we're talking about test networks, there's certain things you can't do according to the terms of service at public cloud providers. So for example, if you read Amazon's one, you're not meant to intentionally put malware onto a system there. Yeah? So if you were trying to create a malware test lab for analyzing malware, then technically you'd probably need to I think technically you shouldn't be able to do it according to the terms of service. So that's one thing with cloud providers in general, and I monitor all the terms of service for all the major cloud providers, and they change these things really regularly, and they don't often email you. They only email you if it's a particularly significant change. But the funniest change is when Google changed their terms of service, obviously didn't mention it, and said that you weren't allowed to use Google App Engine for anything to do with nuclear weapons development. Okay, cross that off my list then. So let's briefly talk about cloud networking, because starting up a bunch of VMs, that's nice. You can get them all like robots doing the same thing. But in this case, we need to simulate networks. So we need a way to string them together. So the first thing to bear in mind is that if we take Amazon as a really great example, you only have one network interface card on an Amazon VM. Yeah. So you have to use Amazon security groups to do anything. For example, to have like a multi-tier web setup, you'd have to use Amazon security groups as a way to kind of associate traffic flows with different systems. Well, that's not very cool, because we just want to use regular routing, really, or routing for my American friends. And the thing is that the routing options are pretty limited, and so therefore that puts a bit of a kibosh on being able to set up simulated networks. So we need a way around that. Also, just to mention it, they have basic firewall set up. Amazon by default, when you spin up a VM, doesn't allow any traffic. You have to tell it, I want SSH or whatever else. So overlay networks, this is Wikipedia, and because obviously they know what they are. And it's a computer network which runs on top of another computer network. So it's a VPN. It's one way to talk about it. So we need essentially a VPN infrastructure. Now, on the subject of VPN, the cloud providers are obviously aware that people like to be able to connect there. Some people want to connect their enterprises perhaps up to a public cloud, and so they provide the virtual private cloud, which basically is they run a VPN gateway on their cloud, and you're able to access that. If you set up the necessary stuff on your side, you have a site-to-site VPN. Site-to-site VPN is preferable to having all the virtual machines that you spin up